All right, now we're going to talk a little bit about standardized scores or Z-scores, which is what we'll refer to. A Z-score is going to tell us whereabouts on our bell curve the score, the number that we're dealing with lies. So it might be like here, might be like here, might be here. We want to know where it is. So if we do our calculations and say the Z-score is 0, that's going to indicate the score that we're dealing with, the number we're dealing with, is right at the mean. So it's equal to the mean. So we do our little calculations and we find that it's equal to 0. It's going to be right at the mean. And if we have a negative Z-score, it's going to be below the mean. So it's going to be somewhere below here in this region somewhere. And obviously if it's going to be positives for our Z-score, it's going to be above the mean, somewhere here. And what's really handy for Z-scores is that if we have a Z-score of 1, we know that it's exactly 1 standard deviation above the mean. So if it's exactly 1, it's right here on this 1 standard deviation above the mean. Obviously that means that if it's negative 1, then it's going to be right here, 1 standard deviation away from the mean, but on the left hand side, so it's negative. So this Z-score we can calculate by using this little formula. So it's going to be x take away the mean divided by the standard deviation. So the Z is the Z-score in this formula, or we call it the standardized score. And x without the line is the actual score or the value, and x with the line is the mean, and S is the standard deviation. So let's put this into use. So here we have a data set of 20 students. This is test results out of 25. And the data is here. So first question asks, calculate the mean and the standard deviation. Now, you're obviously not going to do this by hand. You're going to use the CAS. I will not go through how to do it on the CAS. We've done it multiple times. Refer to the last 2 lessons where I showed you how to do it, or ask me in person. So use the CAS to calculate the mean and the standard deviation. Just as a reminder, we're looking for this symbol for mean, this symbol on the CAS for standard deviation. And hopefully you found that the mean is 14.25. So try this out. If you like some practice, the standard deviation is 4.88. Okay, so now we found that. We can now calculate the Z-score. So we want to calculate the Z-score of a student who received a result of 16. So to do that, we simply follow that formula where we write Z equals the actual score that we're dealing with. In this case, it's 16. So 16, take away the mean divided by the standard deviation. Again, just put this all into your CAS. It's going to give you a number, 0.36. So this is going to be the Z-score for this person who got 16. We know then this person on our bell curve, if this is the mean, we know this person, and let's say this line is 1 standard deviation higher. If this score was 1, this person will be right here, but it's less than 1, 0.36. So this person is like somewhere here. It's just a little bit above the mean. If it was negative, it's going to be sort of on this side. Now, why do we care about this z-score? Now we learned how to do it. Now we want to learn why we do it. So the why is that, so this is very much real to you. This hits you hard because it's very much like how they calculate the VCE scores. Obviously that's a little bit more complicated, but it's the same idea. Example, having a higher mark on one test and a lower mark in the other doesn't necessarily mean you did worse in the other one, because we disregarding the fact that the difficulty of the tests. So like the algebra test, which this person scored higher on compared to the measurement test, could have been easier. Could have been harder. We don't know until we standardized the test, meaning we put everyone into this curve, this bell curve. So we find the mean and we put the mean in the middle. It could be 50, it could be like 37, it could be anything. It could be really high. If it was a really easy test, it could be like 74. And obviously if this is 74 and we found our standard deviation to be like 3, like this is 77, this is like 80, 71, 68. And let's say you were very happy for this test and you've got a score of, so let's say you are X. So without looking at this bell curve, you got a score of like 65 and you thought you did quite well. But turns out this was a really, really easy test with the mean of this and the standard deviation of this. So 65, you are down here. All the way down here. You're in the very, very lower end, unfortunately. Meaning that you will have an adjusted mark and your score will go down a lot, probably into like 10. Hopefully it will never be the case of you for general maths or for any other subjects in VC. But this is why we use the z-score. It tells you sort of where you are on this curve and adjust your score accordingly. So let's look at this example together. So this example here tells you scored 82 on your algebra and then 78 on measurement. But for the algebra test, the mean was 62 for the class or for the cohort or for the state even. And the standard deviation was 10. For the measurement test, mean was 66, standard deviation was 5. Now, without looking into it too much, let's do the first question, the z-scores. So for algebra, let's do in this color, blue. So we're doing in blue. Z-score is going to be your score, 82, take away the mean, divided by the standard deviation, which is 2. It's 20 divided by 10. And let's do the measurement test in this color. Your score is 78, the mean is 66, and standard deviation is 5. So if you do that, that's 2.4. So even though you did better on the algebra test compared to your measurement, the z-score is higher for the measurement test than the algebra test. Obviously, that's taking into consideration of the mean of each test as well as the standard deviation. So we can draw the conclusion that the measurement one was harder and your result is actually better for the measurement rather than your algebra, even though your algebra has a higher score. So just to give you a bit more understanding, more context of this, if we draw two bell curves, and like this is the mean. For the algebra one, you have the z-score of 2, so you did well. You're 2 standard deviation higher than the higher than the mean, so you're 2 higher. But for the measurement, you are not only 2 higher, but 2.4, so 2 and a bit higher from the mean. So even though the score is lower because it was harder, so look at the mean and the standard deviation and everything, you've actually done better in comparison to the rest of the cohort or the class for the measurement test. So you could write for this answer, measurement was better as it has a higher z-score. That will be enough for something like this. So z-score sort of tells you your score, or sort of tells you where you're at in comparison to the mean, so in comparison to others. The next one is similar. It says this one's trigonometry, the mean 60 and your result is 65, and your standardized score is 0.8. So in this case, you're given the z-score. Standardized score is the z-score, and it asks you for the standard deviation. Now you can use the same formula here. So the z-score, the formula is this: z-score is your score minus the mean over standard deviation. This is a little bit different because you're not actually looking for z. You already know what it is. However, you still write it in at its place, 0.8. You know your own score, which is 65. You know the mean is 60. However, what you don't know is the standard deviation. So you're actually looking for S here. So many ways to find S here. Obviously, if you're good at algebra, you can just solve S by hand. However, my recommendation would be the CAS, to use the solve button. So it could be literally as simple as just going into menu, algebra, solve, and you write down the equation that you have in front of you, which is all of this. So you make sure you include everything, like the equal sign and the letter as well. So 60, what was it, 65 minus 60 over S. You can write S, you can write X, as long as you're consistent. And then you do comma and whatever you're solving for. In this case, obviously it's S. You press enter, it literally tells you what it is. So don't get thrown off by this when you are required to do a bit of algebra. So obviously, if you're asked to find this, it will be easier, but you're asked to find this instead. So all you need to do is use a bit of CAS skills and just figure out that you can solve things on the CAS. This bit here, very similar. We're looking at converting z-scores into actual scores. So we're looking at x now instead of z. So the formula is the same. So I'm just gonna actually not worry about this part here. Sorry, I put it there, I know. The formula is the same. So all we're doing with this formula, again, we just want to know what this is. This is the actual score. So we're rearranging everything. Again, we're doing a bit of algebra. But here it is. You do all of it. This is what you end up with. So if you like put this on the other side, multiply both sides by this, all of that business, this is what you end up getting. So whenever you're asked to find the actual score, not the z-score, and you're given all of these three, you can use this formula if you like. Or you can still use this formula just make sure that you know that you're looking for this, not the Z, and you put it into the CAS accordingly, you'll still get the same answer. We're just rearranging things here. So this is nothing new. It's just written differently. So here you're given a whole bunch of stuff. You're given the mean, which is this. Given the standard deviation, which is this. And you're asked to calculate the time taken if its standardized score was this. So this is the Z score, this is the standard deviation, this is the mean, and you're asked to calculate the actual time taken, which is X. So you're asked for X. In this formula, you're asked to find this. So again, you can use this formula. You can put things in its place like this. That's the Z score. Time taken, you don't know, but you do know the mean, which is this. It's given to you, and you know it's you given the standard deviation as well. So on the CAS, go to solve for X here. That's going to give you the answer. Obviously, you can also use this rearranged formula, which is the same formula, just rearranged. I might do that here. So X is what we're looking for, equals Z times standard deviation plus the mean. Again, it's gonna give you the same answer. And the answer you should get, I have it right here, which is seconds. Amazing. I think that's it.